In this video, I am going to configure single area OSPF. So let's start our video. So first of all, I am going to take three 2911 routers. And after that, I am going to add some switches. After adding the switch, we will connect two pieces to each switch. So let's do it first. Let's connect the switches. Now let's connect the router to the switch. Now let's connect the PC to the switch. Just for similarity, I'm going to use here G0/1 port. So let's configure our first router. IP address will be 10.0.0.1.0. Address is 0/1. IP address 68.10.1. 1 PC. This IP will be the gateway that we have configured on G0/1. Let's ping if we are able to reach the router. So we can reach. Same on the second router. Address will be 10.0.0.2. IP address will be 192.168.20.1. This will be the gateway for the PC. Let's ping once. First two pings are due to ARP request was ARP table was not found. That's why. So in this router, we have to configure one more IP address. G0 by 2 port. Neighboring router. We'll give 192.168.30.1. This will be the gateway for the PC. Let's ping it. So the three router we have configured, we are able to ping locally. So now it's time to configure the single area OSPF. So to configure this OSPF configuration, we can configure it in two ways. First of all, I will write down here. There are two methods. One is to globally uh, use this command router OSPF and process ID. So process ID doesn't need to be unique. In EIGRP case, it need to be same on the both the router, but in OSPF we can take alternate OSPF process IDs. So next we can use this statement network. Suppose you wanted to allow 192.168.10.0, and then we need to give the wildcard mask. So wildcard mask is obtained like this. We have to take the broadcast IP address and subtract the subnet mask. So what will remain like 0.0.0.255. We need to provide this, and then in case of single area configuration, we have to give area number. So 0 is the backbone area. All router must be connected to backbone area. So area 0. This is the command we need to configure for all the IP addresses we have given, like 10.0, 192.168.10.0 on our router. In static routing, we give IP address of remote subnet, but in OSPF for dynamic routing, we only need to give our own IP addresses of the interfaces, because it will dynamically learn all the IP addresses. That is the function of dynamic routing. So another important method is there if you don't remember the wildcard mask. So in this case, you can go to the interface and use this command IP OSPF. One is the process ID and area 0. So we are going to use this method on every interface. So let's check it out how we can enable the OSPF using this method. This is the new method. and the wildcard mask was the old method. So let's configure it. We have to show IP to brief, just say IP OSPF1 area 0. And go to another interface, same command because we are using the single OSPF. On the second router, we have three interfaces. With three interfaces, we need to enable this command. And very shortly, you will see that the OSPF adjacencies will come up. So let's check our first router. Yes, the OSPF adjacencies has come up. IP root. So here O stand for OSPF. So 11 network we have learned from the OSPF and 20.0. The second router, we have learned this network 10.0 and 30.0. Now this router, we have learned 10.0, 20.0 and 30.0 from the OSPF. Let's bring the 192.168.10.2 PC. So we can successfully ping any PC from here. So you can check the trace route also just to verify it. So first of all, it goes to your gateway, then it goes to the second router 10.2, and here 10.2 has the entry of 11.0.0.2 router. So 11.0.0.2 router is the third router that has ARP entry of 30.2. So the trace is complete. So in this way, you can configure the OSPF single area configuration. Thanks for watching.